Okay, this is Mr. Gillum, and today we're going to graph quadratics in intercept form. Yesterday we graphed quadratics in vertex form, where the vertex was obvious in the equation what the vertex was. Today what we're going to do is we're going to graph them in intercept form, where you can see both of the x-intercepts right off the bat. Okay, in intercept form, okay, it looks something like this. It looks like y equals a, okay, and a does the same stuff as in every other a, okay, if it's positive, negative, all that stuff, okay. If it's positive, it holds water. If it's negative, it doesn't hold water, okay. That all determines your min, max, all that stuff, okay. And actually what these are factored terms, okay. These little groups right here, they're factored terms. So what we're going to get into is we're going to get into a little factoring here, okay, before long. Before we do that, though, we're going to do a little foiling. But as you can see, okay, it says the x-intercepts are p and q, okay, and they're both the opposite of what you think they are. So if this is x minus 3, one x-intercept will be at positive 3. If this was x minus 4, one intercept will be at positive 4. If it said x plus 5, the x-intercept will be at negative 5. So similar to what we've done before, okay? Just the numbers in the parentheses are both of the x-intercepts, all right? The x-coordinate of the vertex is halfway between p and q, all right? And let me just try to explain to you what's going on here, okay? If I have two x-intercepts, no matter where they are, let's just say I have one right here and right here, okay? Because a parabola is symmetric, I know it could go like this, or it could go like this, all right? The vertex, though, has to be halfway in between the intercepts, okay? It has to, because it is symmetric, okay? Both sides of a parabola are equal, all right? If A is positive, the graph opens up, holds water, it'll be a minimum. If it's negative, the graph opens down, spills water, the vertex will be a maximum, okay? So one more time, maximum and the minimum right there, all right? So it's very similar to what we've done in the past, okay? There's a bunch of little key indicators to tell you what and how to graph, all right? So it's going to look like this. Y equals a number times two factored terms, okay? And you're going to find the x-intercepts, and those are just going to be the points, this number comma 0 and this number comma 0. Remember now, both of p and q, they're going to be the opposite of what you think, but they're still those 2 points. Those are two x-intercepts, so those are 2 points on your graph. The x-coordinate of the vertex will be halfway in between those points. So what you can do is you can either add these numbers and divide by 2, p and q divided by 2, or you can just count the spaces and just meet in the middle. That'll be where your vertex, your x-coordinate of your vertex will lie. Okay, once you have the x-coordinate of your vertex, you're going to plug it in the equation to find the y-coordinate of your vertex. Once you have your vertex and your 2 points, you can connect the dots, okay, draw your axis of symmetry, all that fun stuff, label the max and min, and do all that from there. So this is one of my favorite ways to actually graph parabolas or quadratics, okay? What I'm going to do is this. All right, my given was y equals a times x minus p times x minus q, and really the p and q, they don't really mean anything. It's just p and q. They represent numbers. Okay, in this case, p and q are 3 and 7. All right, the x coordinate of the vertex. I'm getting ahead of myself. P and q, this guy and this guy, right here. Those are the x-intercepts. So I'm going to go over to my graph, and remember, I have the x-intercepts will be at the point positive 3, 0, and 7, 0, all right? And they're the opposite of what you think, okay? And I'm going to go ahead and graph them right away. 3, 0, and 7, 0, right there. Now, as of right now, so I'm going to do a little sketch here. Don't draw this on your paper. I know that my parabola either goes like this somehow, or it goes like this somehow, okay? My a value is going to tell me which way it goes. Obviously, my a value is positive 1, so it will hold water. So I'm leaning towards this. It's going to look something like this. However, it's not enough just to sketch that point, okay? What you need to do is actually find what the vertex actually is, okay? So I know what it's going to look like. I just need to figure out what the vertex is. One more time, I'm going to plot my x-intercepts right there and right there. Okay, halfway in between those should be my vertex. So what I can do is either I can count over, okay, go over 1, finally right here. I know my axis of symmetry is going to have to be right in the middle of those points, okay, which is what I just did there. However, if it's not always the best way to count because sometimes you might end up halfway in between somewhere. This is my axis of symmetry. So what you can do is you can take P plus Q divided by 2. And this is the x coordinate of vertex again. Okay, so I can take 3 plus 7 and divide it by 2. That's 10 divided by 2, which is 5. So I know my vertex's x-coordinate, if I'm talking about my vertex, the x-coordinate of it will be at 5, which when I look at my graph, I already have my axis of symmetry through the x-coordinate, so yes, that would make sense. All right, but I need my y-coordinate still, so I'm going to plug it in the equation to find my y-coordinate. Y equals 5 minus 3 times 5 minus 7. So y must equal 2 times negative 2, or y equals negative 4. Now this is good because we all agreed that it should be a parabola that opens up, and when I plot this point at 5, negative 4, 1, 2, 3, 4, 5, negative 1, 2, 3, 4, right there, the graph is going to be below these. And when I connect the dots here, okay, I do get an upward, or a parabola that holds water, okay, the A value tells me it should have, and I have a minimum value, minimum, okay, my vertex is a minimum, and we're done, that's it, okay, I got my axis of symmetry, my minimum, and my vertex labeled. Let's take a look at this problem, and once again, we just have two factored terms here, x plus 1 and x minus 5, and my A value tells me that it's going to be opening downward, and it will spill water, okay. These, both P and Q, okay, those are just what we're going to call them. P is negative 1, so one x-intercept will be at negative 1, 0, and the other x-intercept will be at the point 5, 0, and those are going to be on our x-axis. So let's just go over here and go ahead and plot those points at negative 1, 0, and 5, 0, 1, 2, 3, 4, 5, right here, okay, and we now need, the only thing left to do is just find the vertex. Well, we could just look at our graph and figure out, okay, well, I know the vertex has to be halfway in between these 2 points because parabolas are symmetric, okay? So I could count and say, okay, it looks like right there is in the middle. All right, that's one way to do it. However, and that just represents my axis of symmetry, okay, what we can do instead is we can take the average of the x-intercepts, the average of negative 1 and 5. Negative 1 plus 5 divided by 2. Now remember, this is the x-coordinate of the vertex. Okay, so what we're doing is we're finding our vertex right now. Will be negative 1 plus 5 divided by 2, and that's halfway in between the two x-intercepts. So my x-coordinate of my vertex will be at 2. Okay. To find my y-coordinate, I can plug 2 in and solve for my y-coordinate, just like a t-chart. You plug in the x's, you find the y's. Well, if I want to know what y is when x is 2, I can just plug it in. 2 plus 1, 2 minus 5. Y equals negative 3 times negative 3, and y equals negative 3 times negative 3, y must equal 9. Okay, so my vertex is at the point 2, 9. Now remember, our A value tells me it should open downward. It should be a maximum value. So when I plot this point at 2, 9, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's way up here, which is good because when I connect my dots, it will be a maximum value. Okay, and so we have a good looking parabola here. And if you're doing P plus Q over 2 first, you can draw your axis of symmetry in second. Okay, it doesn't matter what you do, as long as you have it on there. This is a maximum value. It's the highest point on the graph. Okay, so now we have a pretty good looking graph. We have the vertex, the max or min, and the axis of symmetry, along with 2 x-intercepts. Let's look at one more. Okay, let's go through it again. Okay, my A value is telling me it's going to open up, so we'll have a min value this time, and it's actually going to be a little narrower because the bigger this number gets, the more narrow it's going to be. Okay, the x-intercepts are at 4, 0 and at negative 1, 0. All right, so I'm going to go ahead and plot those points right now at 4, 0 and negative 1, 0. And instead of just counting this time, let's do it legit. Let's find the average of P and Q. So this is for the x coordinate of vertex. Okay, and that should be equal to P plus Q over 2. So halfway in between the two x-intercepts is what that is really saying. Okay, so I'm going to take 4 plus -1 divided by 2. This time I get a fraction, 3/2. All right, that is the x-coordinate of my vertex. So if I'm talking about my vertex, I know the x-coordinate is at 3/2. We don't know the y-coordinate yet. So right away, as soon as I find the x-coordinate of the vertex, just like the other day, I know that the line x equals 3/2 must be my axis of symmetry. So I'm going to go there and I'm going to go ahead and start drawing it in. X equals 3/2, right in between 1 and 2. I'm going to label it the axis of symmetry. All right, because I know that the x-coordinate of my vertex has to go through that axis. Now, the goal will be to get a negative value for y, because I need it to be in the bottom. I need the point to be somewhere down here on this axis of symmetry so that I can so it makes sense with my graph here, with my a value. So I'm just going to plug in my x-coordinate, 3/2. F of 3/2 equals 2 times 3/2 minus 4 times 3/2 plus 1. Now, I know we're still struggling a little bit with adding fractions, but 4 is really just 8/2. And 1 is really just 2/2. So what I really have is f of 3/2 equals 2 times 3/2 minus 8/2 will be -5/2 times 3/2 plus 2/2 will be 5/2. So total, I'm going to cancel out these. -5 times 5 is 25 over 2. Okay, so I have f of 3/2 equals -25 over 2. I cross-canceled here. I took -5 times 5 is -25, and I took, since there's only 1's down here, 1 times 1 times 2 is 2. So my vertex is actually 3/2 -25/2. So it's going to be really, really low down here. Okay, so I'm going to go over 1.5. I'm going to go down 12.5. So there's 10, 11, 12 and a half. We'll just call it right there. Okay, so that 2 really made it a steep parabola here. So I'm going to connect my dots. Okay, try to make yours a little more neater than mine. Okay, and there you go. You have it. You have your parabola. All right, and once again, we didn't even have to use a t-chart. Okay, in this case, we said at the beginning, because of our a value, we should have a minimum. Okay, our a value says we should have a minimum. It is a minimum, so I'm going to label it. And also, okay, we agree that it should look like this. It should look like this, and it does. So we have a pretty good looking graph here. Okay, now let's talk about finding the minimum or the maximum value of a function. All right. The first thing you do is you find the vertex starting with the x-coordinate, okay, by using either p plus q divided by 2, which is just what we learned today, halfway in between the x-intercepts, or you can use the opposite of b over 2a, which I kind of refreshed you with in these previous slides, okay, if you have it in standard form. It just depends on what form the quadratic is, okay, and you need to recognize what form it is in. You plug the x-coordinate in to find the y-coordinate, and that gives you your vertex. Your a value will tell you whether it's a maximum or a minimum, and then you're done after that. Once you have the vertex, you don't have to graph it or anything. Okay, so let's just find the minimum or the maximum value of the function. Okay, first let's just determine what it's going to be. I know my a value in this case is positive, so I know my graph is going to open up. I'm going to say right now, whatever my vertex is, it will be a minimum. Okay, just by looking at that first number. I need to find my vertex though. Okay, so if we visualize this, that means I have a point at -4 and a point at -3. So somewhere halfway in between there has to be my vertex. So what I'm going to do is I'm going to say -4 plus -3 divided by 2. Okay, and what this really is, since this is vertex form, is this is really p plus q divided by 2. P and q divided by 2. And we did this a little earlier. -7 divided by 2. That's the x-coordinate of my vertex. Okay. Right there. I still need to find my y-coordinate of my vertex though. That's a comma. All right. So what I need to do is I need to plug my x value in. Y equals -7/2 plus 4, -7/2 plus 3. And once again, okay, I know fractions are a little rough for us still. 4 is the same as 8 halves, and 3 is the same as 6 halves. So when we add our fractions, we do need common denominators. What I really have here is 1/2 times -1/2. All right. When I multiply straight across. So y must equal -1/4. All right, -1/4. So there's my vertex. My vertex, what we know from prior knowledge, is always the maximum or the minimum. And we determined right off the bat, right away, that the a value was positive, meaning it was going to open up. So therefore, this must be a minimum. A minimum. So you could actually, what I want you to write is min at the point -7/2, -1/4. That's what I want for your solution right there. Let's do another one of those. Okay, once again, before we even start, let's just figure out, are we finding a maximum or are we finding a minimum? This -4 tells me it's going to be a very steep parabola opening down. However, the important part is it's going to be a maximum. Okay, and it is in intercept form this time, so really we have a P and a Q. Okay, and if you think about it visually, we have one intercept at +1 and one at -3, so it should be halfway in between here somewhere for our x-coordinate of our vertex. So what we're going to do is we're going to average these 2 points together. It has to be halfway in between. So 1 plus -3 divided by 2. I know that -2 divided by 2 equals -1. Therefore, now remember, this is the x-coordinate of the vertex. When it's in intercept form, you do P plus Q divided by 2. All right, and we decided P was 1 and Q is -3 divided by 2. We get -1. So the x-coordinate of my vertex, let's say, label this vertex, will be at -1 something. To find the y-coordinate, we need to plug it in. Y equals -4 times -1 minus 1 times -1 plus 3. So we'll just say y equals -4 times -2 times 2. This makes 8 times 2 is 16, so the y-coordinate must equal 16. So my vertex is -1, 16, and that should make sense because I need it to be above, right up here somewhere, so it makes my parabola. It is. So for my answer, I'm going to say, I know it's a maximum because of my a value was negative. It'll open down, and this is the highest point. It'll be a max. So I'm going to say my max is at the point -1, 16. And that's my solution. All right, but I'm not done yet because what I need to do is this. Okay, this time I'm given vertex form, and I need to figure out, is this the minimum or the maximum? Okay, and these go a lot smoother than the vertex form, or than the intercept form, because I know what the vertex is already. It's -2, 3. -2, -3. Excuse me, -2, -3. This is the vertex. It's just plain as day right in the middle of the equation. Okay, h and k are right there for us to see. A value is positive, therefore it opens up. It must be a minimum value right there. And remember, the minimum or the maximum is always the vertex. So I'm going to say there's a minimum at the point -2, -3. And so these, you want to see the ones that are in vertex form because those are the simpler ones to do. Okay, much less work than in intercept form. Let's just do one more vertex form just so everyone remembers what we've done in the past. Okay. The vertex is just right here for us to see. It's at 2, -5. Remember, this h value is the opposite of what you think it is. It's the opposite. Okay. So the vertex right away we know is 2, -5. So these are the ones that are nice to do. I know the vertex is always the minimum or the maximum. I need to look at this 1/2 to determine whether it's a min or a max. It's a positive value, so my graph will open up, and I know it's a 1/2. It's a little number. It's a fraction, so it's going to be a wider parabola, really. That's what it's going to be. But the important part is it's going to be a minimum at the vertex. So my answer is going to be a minimum at the point 2, -5. Okay. Let's look at what